Dear friends, welcome again to my YouTube channel Bilal Sir School of Mathematics. Today we are going to discuss another interesting topic, that is LCM and HCF. LCM is the least or lowest common multiple and HCF is the highest common factor. We know that two numbers may have many common multiples, but the least of all the multiples is called the least common multiple or lowest common multiple, and two numbers may have many common factors, but the highest of the common factors is known as the highest common factor. This can be illustrated by taking a simple example. For example, in previous lecture we learnt about the fundamental theorem of arithmetic that states every composite number sorry that states that every composite number can be uniquely expressed as a product of primes. So with the help of that prime factorization, we find the LCM and HCF of two numbers. Let's take a simple example. We'll take two numbers 8 and 20. 8 and 20. Let's try to find out the LCM. LCM and HCF of 8 and 20. We all know that the prime factors of 8 are, you can see if we will use the tree method, that is 8 can be written as 2, 4, and this 4 can be written as 2 and 2. 2 2s are 4. Likewise, this 20 can be written as 2 10s are 20. This can be written as 2 5s or 10. This is the prime factorization of 8. This is the prime factorization of 20. So 8 can be written as 2 cross 2 cross 2, and 20 can be written as 2 cross 2 cross 5. Now let's try to find the LCM. So LCM of 8 and 20 will be, it will be the C. We have to make the like pairs, and from the pairs we have to take one. इनमें से आप हमें एक चूज करना है, इन दो में से हमें एक ही लेना है. To find the LCM we will take 2 from these two. From these two we will take this, and remaining as these are 2 and 5. This is 2 cross 2 cross 2 cross 5. 2 2s are 4, 2s are 8, and 8 5s are 40. This will be the LCM of 8 and 20. And what is the HCF of 8 and 20? It will be simply highest common factor. Highest common factor. There is no common factor with 5. 5 is not a common factor. 2 is a common factor. This 2 is also a common factor. So we will take this. This is a common factor. In these two, this is a highest common factor. It is 2 cross 2. It is 2 square, and that is 4. That is 4. This is the highest HCF of 8 and 2. It is the HCF of 8 and 2. Now see, if we will see this LCM, we can see that LCM of this LCM, it is the product of highest because it can be written as 2 cube into 5. It is the product of highest prime factors, highest power of prime factors. And this HCF, it is 2 square, it is 2 cross 2, it is 2 square, it is 4. It can be written as the product of lowest power of prime factors. Lowest power of prime factor. This can be written as product of highest power of prime factors. Now see, another interesting fact that we can get from this, that is, if we take the product of this LCM and HCF, see, LCM of 8 and 20 into HCF of 8 and 20. What is that? LCM is 40. You can see LCM is 40 and HCF is 4. It becomes 160. 160. And what is the product of numbers? Product of numbers, that is 8 and 20. Product of numbers is 8 and 20. It is also 160. So we can write in general that LCM of two numbers, if we have two numbers, say A and B, we can write it as LCM into HCF. LCM of two numbers A, B into HCF of two numbers A and B, that is equal to product of numbers. That means A cross B. A cross B. See, what we have got from this. If we have two numbers A and B, then we can write H your LCM of A, B cross HCF of A and B, it will be equal to A cross B. That is product of numbers. Product of numbers. This is the general concept that we got from this. That is LCM of two numbers into HCF of two numbers is equal to the product of those two numbers. From this we can find if the two numbers are given and one of them is also given, we can find the HCF if LCM is given, and if HCF is given, we can find the LCM. You have to remember this. Now, can this hold for three numbers? Can this hold for three numbers. LCM of three numbers into HCF of three numbers A, B and C. Will that be equal to the product of three numbers A cross B cross C? It is an interesting question, that shall or will this concept be satisfied on the triplets? It is an ordered pair. This is an ordered pair. That means it holds on two numbers. Will this concept be satisfied on three numbers, that is on triplets? Stay tuned for the next lecture to see whether it holds for three numbers or not. You have to subscribe and share these videos, and hope that you may have got this today's lecture. We'll meet soon. Till then, have a good time.